Well, good morning, everyone. It's a real honor to be here and giving this presentation to you today. Um, I realize I'm a new face here, and most people don't know me, so I thought I would take a few minutes and just tell you about my background and what led me to APL and to this competition. And then after that, I'll talk about two of my solutions. To the competition. So my background, as far as computing is concerned, starts sometime in the 1980s when I woke up one Christmas morning and found a Commodore VIC-20 personal computer waiting for me underneath the Christmas tree. And one thing you should know about the VIC-20 is that it only comes with 5 kilobytes of RAM. But I didn't care. I was a little kid. I didn't even know what that meant. And I had this flight simulator game that came with it, but because of the 5 kilobytes of RAM thing, the airplane that you were flying had no windows whatsoever. You couldn't see where you were going. All you could see were the instruments in the cockpit, so altimeter and compass and stuff like that. And it came with a printed booklet which described the coordinates of the runways in this landscape and the ground elevations everywhere, and that's how you flew, with the instruments and the booklet. So why am I telling you that story? Well, I guess it's to say that at a very early age, I was exposed to raw streaming data, and I was lucky enough to get to internalize that as play. But other than some, 10 print Michael, 20 go to 10 kind of stuff, that computer is not where I learned to love programming. And in fact, that didn't happen until I got to university. And when I started at the University of Toronto, I took a smattering of subjects. I didn't really know what I wanted to study. And one of the things I took was Intro to Computer Programming. And that's when the love hit, and I knew this is what I wanted to do. So I dropped all my other interests and focused on that, and I took a specialization in software engineering from the computer science department at University of Toronto. And I got great grades, and a few years later I was looking for my first job. And through just random luck, I ended up taking a job with a small software consultancy in Toronto that was run by two guys who used to work for a company called IP Sharp and Associates. And so I started at this job, and I was they threw me in the deep end, and very quickly I was learning C++ on the fly, while I was writing and I was the primary author for a back-end application that was responsible for receiving and normalizing all the trade and quote data from the North American markets and fanning it out to downstream subscribers for this real-time, low-latency online trading system aimed at knowledgeable retail consumers, day traders. And this was in the year 2000, when that was, kind of new, and the data rates from the exchanges were really skyrocketing, and it was thrilling. It was challenging, and it was thrilling, and it was a great opportunity, and I received great mentorship, and it was a great time in my life. And so So I worked on a lot of interesting projects, too many to mention, but 13 years, in 2013, I found myself on a project that was responsible for receiving and warehousing and providing access to all the electrical consumption data generated by smart meters in the province of Ontario. So 5 million homes and businesses reporting up to every 15 minutes, 24/7, 365. So it's a fair amount of data. And my boss was aware of the KDB Plus database product and its Q programming language. And while that had been used primarily in the finance industry up until that point, we proposed it as a solution for this smart meter data project. And then from that point on, I became a full-time Q programmer. And that was a really interesting and exciting experience for me. So I learned how to avoid loops or make them really, really tiny. I learned to avoid conditional statements, and I learned to embrace terseness. And it was a real fertile time for me. And so I did Q for 8 years. And then last year, I decided it was time for a change, and I decided to leave my job. And I also decided it was an opportune time to take a self-funded sabbatical. And then I used that time to rest and to pursue a number of interests, both technical and non-technical. And like a moth to the flame, I found myself drawn to APL. I really enjoyed the growth I'd experienced learning Q, and I was excited I was craving more of that growth. And I'd also started listening to the ArrayCast podcast, through which I heard about the competition. And so those two things are what led me to the competition. And so I got to work, and I spent a few days reading and experimenting, and then pretty soon I'd worked my way through the 10 one-liners of phase 1, and I was ready to embark on phase 2, and I'm going to talk about 2 of those problems now. The first one was a problem called subspaces, and it was working with these things it was called subspace journey, and it was working with this abstract concept called subspaces, which you can maybe see in the background if the font's not too small. Basically, what you have is a field of zeros, and then within that you have some rectangular fields of 1s and 2s and 3s and 4s, and this is sort of the general aspect of the problem. And one of the functions I had to write was something called fill, which was for creating one of these. And so fill was a dyadic function whose left argument described the shape of the overall space, and that took a matrix right argument, which described the subspaces that needed to be created within it. So here's an example, a 5x5 example. So this is the right argument here on the left-hand side of the screen. So each row. So the first row here is a subspace starting at position 2, 2, with a length of 2 and a width of 2, and that's the first subspace. And then if you add another row to the input matrix, it should add another subspace in the result. So here's another one. It's starting at position 4, 4, with a length of 1 and a width of 2, and so on. So hopefully, does the problem make sense, more or less? Great. So here's my solution. And I thought this was a great little kind of warm-up problem. It was fun and educational for me. And so I'm kind of going to breeze through this quickly, but building the field of zeros was easy. It was just a simple run-of-the-mill row. And I was committed to, my last move was going to be a single indexed assignment where I would, set all the 1s and 2s and 3s in one move. And so the rest of it was just trying to figure out, how to populate the indexes and how to populate the labels. The big breakthrough was learning that monadic iota, given a vector, returns an array of vectors, which would be the indexes into to all the subspace shapes, basically. And so if I added those to the starting points, then I basically had all the indexes that I needed to change. And later on, all I really had to do later on with these indexes was flatten them, and I did some edge case stuff. And then for the right-hand side of that bottom assignment, I computed the volumes of the subspaces, which was just a simple product, and then that told me how many of each label I needed, and And that was it. And then I was done. And so I thought that was pretty good. And but even as a guy who'd only written 10 lines of APL in his life at that point, I felt pretty confident that I could create an array of zeros, and that if I banged on it long enough, I could get it to take it to where I wanted it to go. But while I was doing that, I had this sense of dread that was growing in me because I had read ahead to the next part of the problem. And you see, up until now, we were given a spec, a specification of what we needed to build, and we just had to build it. But the next problem, called subspaces, had to go the other way. Given one of these fields of zeros, I had to find the starting points and shapes of the subspaces contained in it. And I didn't know how to do that. So when I stopped panicking, I thought, okay, well, I'm going to try to make this problem easier for myself. So I thought, what if I could just solve this in one dimension? If I could solve this in one dimension, maybe I'd gain some insights. So I created a one-dimensional example, and I started staring. I got to staring at it, and I thought, okay, well, one of the things I need to find is the starting points. And I thought, okay, well, this is APL. There's got to be a way to find the first occurrence of a value in a vector. And so, looked around or researched it, and I found it, index of. And I thought, okay, great. But in order to use that, I needed to know what I was looking for. So I stared some more, and I thought, well, if I took the maximum of this vector, and then I fed it to monadic iota, that would give me the vector 1, 2. And those were exactly the things I would need to be looking for. So great. So now I've got the starting points. All I really need now is the lengths of the runs in the vector. So I went back to looking and staring, and then I thought, well, if I could find the endpoints, I could use that in a subtraction with the starting points and avoiding any off by 1 errors, then I'd have the lengths. So now I just need the endpoints. And I looked some more. I thought, well, I know how to find the starting points. If I reverse the array and I find those and I adjust it by the length, then I'll have the endpoints, and I can do this subtraction, and basically I've solved the problem. So I thought, okay, this is great. I'm getting somewhere. And I knew that APL only supports arrays up to a maximum rank of 15, so I thought 1 down, 14 to go. But my intuition told me if I looked at a 3-dimensional problem, and if I could figure out how to solve a 3-dimensional problem, that would probably work for all ranks. So I created a 3-dimensional example, and I thought, okay, how am I going to solve this? So I got back to staring, and pretty quickly I realized that if I could find the starting points and the ending points in the 3-dimensional space, i.e. the top leftiest ones and the bottom rightiest ones, I could use a vector subtraction from those points, and those would describe the shapes of the subspace. So that was great. Now all I really needed to do was find those starting points and ending points. And I thought, well, how am I going to do that? And then I thought, well, I just figured out how to solve that in a 1-dimensional space. Maybe if I could project this onto a 1-dimensional space, I could just use that. So, and I thought, well, this is APL. There's got to be a way to do that. And so sure enough, I found Ravel. So I played with Ravel, and I looked at that a bit, and I convinced myself that the top leftiest ones definitely ended up at the beginning, and the bottom rightiest ones definitely ended up at the end. So I was in good shape for that, and my iota max trick to find out what I should be searching for, that was still going to work. So that was great. So I could find the starting points and ending points in this 1-dimensional space, and all I needed now was to map these back into the rank n space, which I convinced myself I could do with a little bit of math. But then I thought, this is APL. There's probably a built-in to do that. And not only that, I think I know the name of it. I think it's going to be encode, or maybe decode. I knew it was going to be one of those because back in my KDB days, one performance trick we used to do is if we had these compound keys that we needed to look up into large tables, we would map those onto a scaler to get faster lookups. And we had these user functions called encode and decode to do that. And I remembered their names because I remembered that I could never remember which one was which. And I complained to my boss about it and said, we got to change the names of these things. And he said, Michael, I'm afraid we can't do that because that's what they're called in APL. And so this problem that had been stressing me out and that I'd been worried about turned out to be easy to solve in the one-dimensional case. And then by mapping the n-dimensional case into in and out of the one-dimensional case, the whole problem just melted away on me, which was kind of neat. So, just quickly going through this. There's my ravel to get into one-dimensional space. There's my iota max trick to figure out what I'm searching for. There are my searches. This is where I'm getting back into rank n space. There's my magic encode. By the way, this was my first ever multi-value assignment, which I thought was pretty cool. This is there's the subtraction where I'm computing the shapes, and then the rest is just shaping the result, and that was it. And then I was done with that, and I thought, great. So I felt confident. I had been worried, and now I succeeded, and this really built my confidence. And then that worked, and that served me for the rest of the competition, and obviously it went pretty well because I'm here. And I thought, well, and it was just a great experience. Until I got to problem 6, which, as Brian mentioned, was nasty. It was really brutal. And Brian told me that, my solution didn't have a perfect score for correctness. Which was disappointing to hear, but also I knew that I was rushing. I was up against the deadline. I was one of those guys at the spike at the right-hand side there, in part because of this problem. So it didn't get the level of polish and testing that I normally would have liked to have given it. But the other thing Brian told me is that my solution ran 3 orders of magnitude faster than the most correct solution. And I thought, that's kind of interesting. And I think I'll just spend the rest of my time just briefly describing just at a high level, my approach and how I got that performance. So we had to write a function called DDN. And if anyone's familiar with 1200 I-bar, it's that 1200 I-bar is a date formatter. So it takes a format specifier, and it takes a Dyalog date number, which is a binary representation of a moment of time. It's a temporal distance from some epoch measured in days. And what it spits out is a pretty human-readable string representing the date according to the format specifier. So the function I had to write, DDN, was the inverse of that. So it still takes the format specifier, thankfully, but then its right argument is the string, and I have to parse that into a Dyalog date number. So here's an example from a day earlier this year. Here's another example slightly later on the same day. There's more than one answer. And in fact, if you look at the previous one, we only know the last 2 digits of the year. There's another correct answer for 1922. And there are 60 of these different format strings, and they can come in any combination. So you can have these wild combinations where you might know you might only know that your ordinal is a TH, so you're not dealing with the first or second or third, but any other day of the month. And that might be the only information you know about, month or whatever. So really tricky. I thought it was really tricky. So there's a whole parsing aspect to this problem that I think for time I'm going to skip over, but there's a microphone over there if anyone wants to talk about it. But I had this parse table that I thought was kind of cool and an interesting way to solve the problem, and I'd be happy to talk about it later. And I also went into the piece, the part of Q that I missed the most while working in APL that might be of some interest to folks, so I'll put that out as a teaser. But I want to talk about how I solved the constraint problem and how that worked, how I think it worked really quickly. So basically, trust me, the time part was easy. It was the date part that was hard. And so what I did is there's a kind of an art to this, but I had to pick a list of candidate years that I would take whatever year information I had, which might be none, or it might be the last 2 digits, or let's not talk about ISO week years, but they were another wrinkle. But at any rate, and I'd come up with this list of candidate years. And for each year, so I'd loop over them, and then for each year, I would start building a matrix. And the columns of this matrix would be the days in the year, so either 365 or 366 columns. And then I'd start adding rows, which would be properties of each day in that year with respect to a particular constraint I might care about. So here, this would be what month is each day in. So I have 31 ones and 28 twos and 31 threes, etc. And then another row, which would be the day of the month. So 1 to 31, joined to 1 to 28, etc. And then I could add another row, which might be for day of the week. So 2022 started on a Saturday, and I cycle through 1 to 7 from there. And I would have others of these, but this is sort of the gist of it. So for this year, now I've got this matrix that's full of interesting properties about every day. And now what I can do is I can start applying the constraints that I've got from my input. So for example, I'm going to just zoom in on this is like 3 panes of that matrix. And so if I had a constraint, let's say I had the constraint Thursday. So now I could test the bottom row just to test where the third row equals 4. And if I do something like that, now I've got a Boolean mask where 1s indicate Thursdays. And then I can do that for a month. Let's say if the month is February, 17th, the 17th of the month, so I can do that there, and then I could do it for February. And maybe you could see what I'm setting up to do here, but so now I've got all these masks, and if I do an AND reduce along the columns, what I'll end up with is a vector, and any 1s in that vector indicate days that, by definition, satisfy all the constraints that I have. And so then I can just find the position of the 1 in that vector, and that gives me the offset into the year, how many days into that year that is, and then I can, with a bit of math with the year, basically I could compute the Dyalog date number with that. And so that was sort of the guts of the tricky part of that solution. So, sorry to rush through that, but hopefully that makes sense. I just wanted to say I really enjoyed the competition, and it was really great to come out here and meet you all, and I wanted to thank Dyalog and thank the sponsors and thank all of you for your attention here this morning.